Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live. Tonight we're going to go comet chasing for Comet C20, is it 2019 and Y4 Atlas, I believe. Yep, C2019 Y4 Atlas. So right now we're going to focus on a star, this bright star Procyon, which currently looks like a grill. And that's thanks to the Batinov focusing mask. So let's get that star in focus. That's better. It's close anyway. Now we just highlight the region of interest. Go to 1 by 1 binning. Alright. Okay, that probably made it worse. I think I shot past focus point. Maybe not. Maybe not. Okay. Let's come back the other way. Yep. Okay. So we're just trying to get this diffraction spike to be symmetrical. And honestly, that's probably close enough. I'm probably going to have to refocus the telescope when we get to our target anyway. Okay. Let's see. Alright. It's reasonably close to the bright star Dubhe, so we will move over in that direction with the telescope. Alright, thankfully the adaptive optics gives me greater clearance, otherwise the camera would hit the mount if it were just sitting off the back of the telescope. But this AO7 adaptive optics unit reorients the camera 90 degrees. Okay, so as I expected, actually I didn't go to Duvet, I went to a H Ursa Majoris, in the constellation Ursa Major. It's one of the other stars in the constellation. Reasonably bright as a focusing target. Okay. Get a bit of mirror flop there from drastically moving from about 0 degrees declination to about positive 60 or 70. Whatever I'm at now. 62, positive 62 degrees declination. It's a pretty drastic change in the position of the telescope, so you get some mirror flop. That looks reasonable. Let me tweak it back the other direction, just a smudge. Just a hair tweak should do it. Yeah, that looks good. Okay, I'm going to call that focused. Alright, so now let us move on to the Comet. C2019 Y4 Atlas. Let's get the coordinates in there. Let's go to 2x2 binning. We'll increase the exposure length to 5 seconds. Alright, let's do the slew first. Actually, why do that first? That doesn't make a whole lot of sense. I'm getting carried away. Before we do anything else, we've got one other task to complete for calibration. We have to calibrate the drive system and the adaptive optics unit so that it knows how to turn things. Okay, don't do subframe. Okay. Okay, so auto guide, we will use the main imager for auto guiding calibration. We go to 0.1 seconds. Take an image. Take a dark frame. Okay, cool. Now, we'll make sure to take out the slack in the drives. Just make sure that the north, so you want to take out the slack in the north direction. Otherwise the calibration won't be accurate. Sound like some motorcycles racing on the interstate. Hope you're wearing a helmet. Okay, let's calibrate the drive system. So it's going to move this star around and figure out what direction is what based on the orientation of the camera. The camera can freely rotate, so hopefully it stays in the same orientation. Last webcast I had a bit of a problem where the camera got loose and started rotating during exposures. That could happen again tonight. Something funky about the way the camera seems to work when I've got it screwed into the focal reducer, in that it doesn't really work all that great in terms of the rotation. It doesn't tend to remain fixed. Okay, let me tune up this calibration a little bit. Oh wow, the camera's like perfect. Okay, I never get it that perfect. Okay, calibrate AO. It's like perfectly orthogonal for some reason. I didn't think it would be, but I guess sometimes you just get lucky. So now it's going to calibrate the adaptive optics. So now it knows how to move the star with the drive system, the telescope's motors. And now it's figuring out how to move the star around with the adaptive optics unit. So it's got two ways of moving the star. The adaptive optics unit is, of course, a much faster response, and that's the primary motion. But it keeps it within the range of the adaptive optics unit ability to travel using the motors. Okay, so that's done. Just check the AO calibration results. That looks good. Drive calibration results look good. Okay, now let's move to the Comet. Okay. Alright, we should be pointed at the comet, roughly speaking. So, let's see what the story is. Take a 5-second exposure, 2x2 binning. What do we get? Okay, we get some stars. Let's see if I can line up this pattern. These stars do look familiar. The comet should be close to this double star on the right side here. It's probably this down here, but I want to confirm that. I'm pretty sure that's what it is, in fact. Let's just do a... yeah, we'll do a 3x3 10-second exposure. Trade off more resolution for more sensitivity and double the exposure. Hopefully just pull out a little more light. I just want to confirm that really is a comet, not a star. Oh yeah, that's the comet. Now I can see the fuzziness of it. That is most definitely a comet. Okay. If I flip it vertically to be the same orientation, oh yeah, I recognize all these stars here. Okay. So, now what I'm going to do is I'm going to try to move this star, this bright star right here, to be up out of the view into the auto guider. That'll move the comet way up, of course. And I'm going to try to move the comet to the left. Okay, let's just keep running these exposures at like 3 seconds. Oh, I can't do that? Well, I guess I can. Okay, now I can do that. Okay. That's better. So bear with me, we're going to reposition the view here quite a bit, and this will take a few minutes, because I'm just going to be driving this scope quite a distance to get it where I want it to be, where that top bright star is out of the view, and that, in fact, the comet will be in the upper quarter of the frame when I'm done. Keep driving, keep driving. Those double stars need to be where? They need to be pretty close to the top. So we'll keep driving in that general direction. Oh, why did it stop moving? That's weird. Come on, keep going. No, maybe my... maybe you can only hold down the button so long. I've never held it down this long, I don't think. It probably timed out on me. It thought I was asleep at the switch. I'm not. Okay. I think that's far enough up. We can find out, though. I'm going to stop taking these pictures. I'm going to take an auto-guider picture. Oops. I didn't mean it for it to be that short of a picture. Well, okay, that worked anyway. I was going to do a full second, but I can already see. Yeah, there's that bright star. So now we're going to move that bright star to the left. Hopefully that's the right direction. It might not be. Oh, that is the right direction. Okay. We're going to keep moving that star to the left. Basically as far left and down as we can get it, because the comet's going to be moving to the right in the view. We're going to track the stars using the adaptive optics unit to get the best possible image. So we're going to let the comet drift through the field of view. And for reference, right now the comet is 1.09 astronomical units from Earth. It takes light 9 minutes to reach us from the comet. And this is a nearly parabolic comet. The eccentricity is 0.99919 according to Sky Safari right now. So it's an extremely elliptical orbit, very nearly kicked out of the solar system. Inclination is 45.3 degrees, so it's pretty far inclined to the plane of the ecliptic as well. Keep going, keep going. I'm going to just keep moving that star to the left. Basically as close to the edge as I can get it without going over. And I may move it down a bit too. I probably should. Get it as close to the bottom edge as possible as well, because we really don't need that space down there. Otherwise the comet's going to stop. Right? It's going to start the in this what will eventually be a time lapse. It'll start higher in the image than I would like. I mean, it's not going to be centered in the image at all, by no means, but I prefer not to have the comet just passing through the top of the image. It just looks like I missed or didn't know what I was doing. But there is a method to my madness here. As you can see, I'm basically trying to get this auto guide star to be as far to the bottom left as possible. Okay, that'll do it right about there. And actually, I don't need a full second exposure on that guy. We can go down to 0.1 seconds and do at least 10 Hertz guiding. Yeah, there we go. Okay, it's right on a dead pixel. I'm going to move it a little more, just so it's not on a dead pixel. Okay. Try that on for size. That's better. Okay. So we've got a good lock on that star. Guiding at 6.3 hertz. The star is acceptably bright. Now we're going to set up for auto, well, we already got auto guide. We're going to set up for taking the images. So now we're going to save these images. We're going to go to 1x1 binning. That will give us color pictures. And we'll start off with, should we do 2 minutes? Let's try 2-minute exposures. We don't want to go too long because otherwise the comet's own motion will blur itself in the view quite badly. Even at 2 minutes that might be too long. We'll see. And now finally I can have a moment to breathe and pull up the chat and see what you guys are saying. Mute desktop audio. So I've got a 2-computer live stream setup going tonight. My new laptop and my old laptop. My old laptop is running the camera, and basically I'm HDMI capturing the old laptop to show you guys the view. This is a bit different than last live stream where I was capturing Deep Sky Stacker live on this laptop. But I'm not doing that this time because the comet is going to move over time, and if I just straight stacked on the stars, you would just get the streak of the comet. So in the interest of just showing the comet's current position and basically a live image of the comet, we're going to show the actual computer that's running the capturing. Alright, here comes the first 2-minute exposure, and then it'll now do a 2-minute dark frame once that first image is downloaded. Oh, hi. Okay, so I immediately see, yes, we've got the comet, but we also have a problem. The camera rotated during the exposure. Not ideal. We're still connected to the camera, right? The USB cord's kind of getting pinched in the space between the camera and the mount. That might have been pushing the camera a little bit. It's not ideal. I could rotate the camera 180 degrees, but then we wouldn't have that guide star. We'd have to go find a different one. And I don't know if there is another one that's as well positioned in the opposite direction. Survey says maybe, but not really. Okay. Okay, well, let's see what the next 2-minute exposure does after this dark frame takes its picture. We'll live with this for now, but hopefully we can get a better exposure than this. I'm really not happy about that rotation, and that's because I've got it attached on the focal reducer, and it doesn't exactly stay firm in its rotation. So anything pushing on it over the course of the 2-minute exposure is going to rotate the image. Yuck. Ugh. Okay, let's see what happens this time. Well, okay. Guide star lost brightness. Okay, yeah, because I okay, stop. Stop taking the exposure. Stop it. Just stop. Okay. Okay, we've got the guide star there now. So I did touch the camera during the dark frame exposure, which doesn't matter as far as the dark frame go, but it does matter as far as getting the picture. Okay. Alright, let's try this. So, yes, the comet is nice and bright, very obvious in the view, as I would have hoped. You can even see a hint of a tail going up to the top left, which is where it shows the tail should be oriented in Sky Safari Pro. So I'm pretty confident that is the comet's tail, which is pretty cool, even if the picture does suck because it rotated. Sorry about that. Alright, hopefully this picture doesn't get rotated again. If it does, I will have to find another solution, which I don't want to have to do. I wonder if I could route the USB cable a different way. Problem is, if the camera loses communication with the computer, it's gonna shut down the thermal control. Which is just slightly annoying. Not to mention it'll probably have to take a new dark frame. It's just a waste of time. I don't want to have to do that. Please, don't rotate the camera. I sort of jiggled the cord while I was taking that dark frame. Hopefully it's not pinching as bad now. But that's no promise. No! Okay, it's still rotating. Daggone it. Alright, stop the exposure. This is just stupid. Alright. Plan B. I'm gonna have to disconnect the camera. Am I? Yeah. It's just best. I'm gonna disconnect the camera from the computer. Okay, I think I located the source of a bigger problem than the USB cable. I think it was the power cable more than the USB cable. Okay, so we've repositioned the guide star quite badly again, but at least it's still in there. Okay, let's try this again. Okay, I'm right on a dead pixel. Let's move it. Just move it a bit to a different pixel. More. Okay, that's better. No, no, don't go back onto the dead pixel. What are you doing? Also, I hear raccoons fighting or something. That's nice. I think they're on the next street over, though. They're not even near me. They do this like every night. Come on. No. Guide there. Okay, better. Much better. Okay, let's try this again. New picture. Oh, no. Stop. I see a major problem. Thermal control did shut off. Okay. Temperature. Thermal regulation. Go on. Back to -5. Okay, we're going to have to wait a minute. The camera started warming up already. As soon as I disconnected it, it started warming itself up. Hopefully this will... Oh, hey, we got 91 people watching. Hey, guys. If you're new to the channel, please subscribe. I love doing streams like this. And providing coverage of the latest events going on in deep space. So while I wait for the camera to cool back down to its operating temperature, this camera is thermoelectrically cooled. This is an SBIG ST2000 XCM single shot color camera. And I'm using an adaptive optics system, an SBIG A07, on an 8-inch Meade LX200 Classic. So, we're tracking this comet in deep space here. But for those who are worrying, no, this comet's not posing a threat to Earth. I'm trying to find the minimum distance it gets to Earth. I think looks like it's somewhere around 0.78 astronomical units. Somewhere in that distance. Just a matter of about 2 months from now. So, yeah, it is brightening up quite nicely, but you still need a telescope to see it. Maybe you could do binoculars, I don't know if it's really bright enough for that yet. Okay, the camera's cooling down quite nicely, but it's actually shot past the set temperature. It's gone down to -6.5. I'm going to wait for it to come back up a little bit. So, it will take dark frames. The dark frames are, well, really best if they're at the same temperature as the actual images. So this camera is able to hold a set temperature. So it's best to get those dark frames in at that same temperature. So it's shot past the set temperature. We'll wait for it to figure out what percentage power it needs to apply to actually maintain -5 degrees Celsius here. What is going on the 22nd? Hey, Global Throttle. Not sure what you mean by that question. Are you talking about an asteroid, a comet, or are you talking about a rocket launch? Not sure what you're referring to there. I'll have to check spaceflight now. If it's a rocket launch, I'm not sure what's next on the schedule. Okay, this is good enough for auto-guiding purposes. Let's go ahead and start the auto guider up. Okay, we're now auto guiding. Alright, let's try another 2-minute exposure. So I rotated the camera slightly to hopefully prevent the power cord from nudging the camera, which I think it was doing because it's coming up against the mount. I mean, really, I think I'm going to end up having to rotate the camera 180 degrees and just live with that. And yeah, Global Throttle, thank you for your subscription. Appreciate it. Next is Atlas 5 on the 26th. That's kind of what I thought, Dummy Joe. It was going to be around then for the next rocket launch. Yeah, that sounds right. Yeah, we broke 100 viewers tonight. This is unusual for me. Yeah, Sam, it'll be interesting to see if SpaceX maintains their schedule for the launch on the 30th. I saw that Elon Musk tweet where he said an investigation was needed to figure out what happened with that engine failure before the next mission. Oh, is that the SOCOM 1B? That's cool. I mean, personally, I'm not super worried about it since it was the 5th flight of that booster. It's not like that was a brand new engine by any means. But they probably do still need to figure out what happened there. Because, you know, they talked about that rocket being able to fly up to twice that long before needing major refurbishment, and that may not be the case if they start to experience major engine failures, you know, halfway through its design lifespan. Oh, thank you, Resonator. I like that name. Resonator there. Alright, hopefully, let's see what happens. Hopefully we have solved the problem of the rotating images, but I have a feeling there's about a 50% chance it hasn't actually fixed anything at all. But we will get it fixed one way or the other. By golly, we will fix it. Okay, let's see. Here comes the image. Hey, it's fixed. It's fixed. So, for the most part, I think we've solved that nasty rotation. There is still a little bit. It's not really prevalent, but to my eye, I can kind of see it at the edges here. These stars are slightly elongated by what is probably some residual rotation, but it's not nearly as noticeable. And in the center of the view, you can see the comet really looking nice there with its tail. Let's see. I know there used to be a way to take this image and make a grayscale version of it. Color combined. I could extract the color. Convert to 1 bit or no. Oh, I've got the wrong one selected. Okay. Convert to grayscale. No. Here we go. Okay, that really didn't help. It really is an 8-bit grayscale. Okay, I thought I could, like, play around with the levels some more if I converted a grayscale version, but no, it doesn't let me. Yeah, okay, CCD soft is not the best. This is old software, for sure. Okay, and we're getting rotation again. Alright. I've had enough of the rotation nonsense. Stop it. Okay. Let's fix this problem. Even if it means I have to rotate the image 180 degrees, by golly, I'm going to fix it because I'm tired of this nonsense. We had one good picture. Okay. All right. Extreme measures are called for. I want to be done by midnight here, so didn't want to have to do this, but I'm gonna have to do this. Since it's sitting there loose on the focal reducer and I can't get it to tighten up like it should, I'm gonna go back to a bright star like H Ursa Majoris, and I'm going to take off the focal reducer and secure it to the back of the telescope directly. This will increase the clearance between the wedge and these cables that keep hitting the wedge, and it will allow me to tighten up the camera better so it doesn't freely rotate. Alright, let's do this. Okay, first of all, let's not save all these pictures I'm about to take. We're going to have to refocus the camera and all that fun stuff. I apologize, but we will get there. Just have to solve this little technical problem. Okay, now let's verify that I'm pointed at the star I expect. Yep, there's the star I expect. And let us... Alright, I'm going to center up this star a bit. So, the fun thing about taking off the focal reducer, which isn't necessarily a good thing, though you might think it is this will also increase the effective magnification of the camera. Yay, we get to zoom in. Okay, but the problem is the comet is moving constantly. So that means you can't expose for as long before the comet starts getting motion blur. Is something hanging down causing rotation? You could always blame it on your cable management team. Yeah, no, it is totally the cable management team. Unfortunately, that's me. But it's because the power cable keeps bumping up against the wedge. There's very little clearance between the camera and the wedge, and the cables can just barely fit between. What in the world is that? You guys seeing that? Oh, that's like a lens flare or something? Oh yeah, it's a reflection. As I move the star, it moves. Oh, that's wild. Woo! I can make a UFO. That's cool. Alright, so now the star is reasonably well centered. Alright, now I'm going to take off the focal reducer and we'll have to refocus. Camera's off. See, the problem I think the real root cause of this problem is this comet is very high in declination. 60 something degrees declination, 67 degrees. So when you're polar aligned, like my telescope is, with a fork arm, the telescope has to pass between the forks when it's that high in declination. And that leaves very little clearance for the camera. Huh. Okay. Okay. So I don't know exactly what's going on, but the camera's not locking down like it should, even with the focal reducer off. That's the first time I've had that problem. Maybe something came loose here. I'm trying to see. I mean, that should. That should lock it up tight if it gets all the way on the threads. Okay, one more time. have to move the scope. I just can't get the threads up there when it's at this angle. Yeah, that's better. Okay, I got it back on there. All right. Whew. Okay, I think I figured out the mechanism and why it wasn't holding on tight. Now it is. So that problem's solved. So we will get back on to focusing here. Hopefully. Okay, yeah, the star we want to focus on is in the view. That's good. Okay. So once again, we will focus on a star, then we'll move closer to the comet and focus on another star. Okay, so... Alright, let's slew closer to the Comet now. Okay, that's good. The cables get close, but now they do clear. So we should be okay. Hopefully... Yes, okay, good. Our target star is right where we expect it to be. Okay, now let's focus on this guy. Make sure the focus is tight. Oh, look at that. That's not too bad. That's not too shabby. Just gonna tweak it a little bit. Okay, that was the wrong direction. Tweak it a little bit the other way. Nope, nope, that was the right direction. Okay. A little bit the other way. A little bit more. I don't know, did I go the wrong way again? No, I went the right way. Perfect. Perfect. Okay. Right there. Okay. So, now we're ready to go back to the Comet. But we will... Oh, we're not quite ready. We're not quite ready. We need to recalibrate the autoguider. Sorry. Okay, we'll have to do this step again. Okay, abort that. Subframe off. Go to 0.1 seconds. And take a picture. Okay, cool. Now we will calibrate. Because we moved the camera, I completely removed the camera and took it off and then put it back. So we have to redo this step. I apologize. Oh, wrong imager. Yeah, we're going to be viewing Comet C2019Y4 Atlas. Okay, let's see. Let's take out the slack. Come on, get rid of that slack. Okay, there we go. Calibrate the drive. Go for it. Oh. Whoa. The chair's falling off the pavement again. Okay, drive calibration successful. Let's tune this up. It's supposed to be symmetrical in both the positive and negative directions, but it never is due to slop in the gear, so I give it a little extra. Okay, we're no longer quite orthogonal, which is why we redid the calibration. We will center up the adaptive optics unit and then well, let's see. Let's take an image first. Okay, now we're going to calibrate the AO. So it's going to move the adaptive optics in all 4 directions and check the alignment there. Whiskey Sadie says that they hear the comet is passing Mars. Now, that may be true as far as the distance from the sun, but it's not physically near Mars in the sky. Okay, so calibration's done. Alright, I think we're ready to go back to trying to get the comet. Alright, now we can start taking new pictures. Okay, this is going to be 2 minute, no FR, no focal reducer. Let us take a 1 second image here, 3x3 bending. He looked for me at Port Canaveral. Why were you looking for me at Port Canaveral? I wasn't at the launch the other day. Okay, looks like... Okay, looks like that is kind of where I expect things to be. Oh, no, what? Why would I try to take a 3 minute picture with the auto guider? That's hilarious. No. Okay, good. So the auto guide star is kind of where I want things to be. Ultimately, we will take pictures of the main camera. So I'm going to move the auto guide star all the way to the left, which should get me in good position for the comet. How long an estimate will this become near? Well, the closest approach to Earth will be in about 2 months. But it's going to get close to the sun in the sky, so at that point I don't know how visible it'll really be, but it's supposed to get bright. It's supposed to get naked eye bright enough to see by naked eye, but whether it will actually be visible is a question. It's possible. But even at its closest, we're still talking about 3/4 of the distance to the sun. So, not all that close. Okay, start the auto guider. Beautiful. Okay, we are auto guiding. Now we will turn on autosave. So we save these pictures. We will do 2 minute exposure. Oh, hey, we've got a super chat. A couple super chats. For $3 from Jack Burton, it won't let me send Tree Fitty. Damn it. Monster. Oh, that's from South Park, isn't it? I'm sorry. I'm not hip, but I do recognize that reference. Okay, start the exposures. And from 199 from Andrew Kroll, wait for it. Yes, now we wait 2 minutes for it. The first truly good picture, hopefully, that I got of this comet. We're focused, the camera's locked in place, it's not going anywhere. It should be good. I feel like a dum-dum for having the camera just loose there before where the cables could push it. But that should be taken care of now. We've got 125 watching. That was quite good. A lot of interest in this comet, it seems. Well, if you guys like this, maybe I'll have to go for this comet again. Follow it over time as it gets closer. Right now, it's basically circumpolar from my location, so it never rises and it never sets. It's close enough to the North Star that it stays above my horizon here in Florida all the time. At least for the moment. It won't stay that way, but for the moment. Did I read Lucifer's Hammer? No, I haven't read that. That's classic sci-fi, but I haven't read it. Eric Briggs. I assume you're the good Eric Briggs, not the catfish Eric Briggs. I'm pretty sure you're the good one. And I apologize that you share the name of the other Eric Briggs. Mike Gov Insider just spoke incredible info on Paul Begley channel just now. What's inbound before Atlas shows is a major concern. Really? Paul Begley. There's a name I don't hear very often anymore. Paul Begley promoted the nonsense regarding the so-called ISON UFO, where he promoted the conspiracy theory that ISON was actually in 3 pieces. In fact, it was a multiple exposure of Comet ISON taken from Hubble, and I showed that was just due to parallax. It was quite normal. There we go. There's our little comet sitting there. Nice round stars, not streaked by abnormal rotation of the camera. Much better. Got a little bit of coma, but I'll live with it. That's probably due to me needing to recollimate the telescope, I'm guessing. But I'll live with it. As for the comet, it's down there kind of in the bottom right. And it's going to move down to the bottom right over time. I wish I'd got on it a little sooner, but, well, technical difficulties being what they are, I had to deal with it. Okay. Well, okay. I'll do it like this. I want to be able to keep an eye on my auto guide star. But also the comet. Okay, there we go. That works. Now I can see the auto guide star and the comet. And we should see the comet move over time. So, what's Paul Begley claiming now? He says, what was the comment again? What's inbound before Atlas shows is a major concern. What's inbound other than a pandemic virus? Okay. Sun could change its directory? Surely not this way, but just to knock it off in a bit different direction. No, the comet can't knock the sun off in a different direction, nor can it knock the Earth off in a different direction. It's not going to hit Earth, so it's not going to affect our trajectory. There we go. Auto dark applied. Now we have a much cleaner image. We got rid of all those hot pixels, all those colorful pixels. Those were just defective pixels on the camera. That's to be expected. Those are just hot pixels. Hello, Paul McBay. Sorry, I'm still getting caught up here on the chat as I'm trying to monitor what the camera's doing. How many degrees from North Star in what direction on a clock face? Well, depends on what time of night you're looking at it. Right now, it's basically crossing the meridian. It's close to that point. So it's basically directly above the North Star. And it's roughly, what would that be? It would be roughly 20-something degrees away from the North Star. Close to 23 degrees above the North Star. Will the James Webb Telescope change astronomy? Probably. Probably. What constellation is the comet in? Ursa Major, I believe. Pretty sure, I mean, it's very close to Ursa Major. I'm pretty sure it's inside the border. Let's see. Yep, it's inside the border. It's in Ursa Major officially. So Big Dipper. Most people know it as, but it's actually Ursa Major. You'll be posting a Comet Atlas video. Yeah, Eric, you have pretty good equipment, don't you? I'm sorry, I can't remember everyone's equipment, but I recall you taking some pretty good pictures in the past. You'll probably beat whatever I'm able to produce tonight. Who's Mike? Paul said nothing. Mike was speaking on virus and also inbound burning rocks. Who's Mike? I don't know who Mike is. Sorry. Your guiding sampling is very fast. Yes, it is. That is the beauty of the adaptive optics unit. So this AO can respond much, much faster than the telescope's drive system, which is the reason why it's able to get these super tight stars even at f10. This is no focal reducer here. This is f10 on an 8-inch LX200 Classic, the default mount that it comes with, okay? Not a proper German equatorial mount here. This is just the fork arm mount that it comes with on a standard wedge, a Meade standard wedge. Not high-grade equipment. It should not be able to track this accurately for 2 minutes, but it is thanks to the adaptive optics, which is sampling at probably 6 hertz right now. Yeah, close to 7 hertz, 6.8 hertz. So it's making 6.8 corrections per second on the guide star. Where will it be tomorrow? It'll still be in Ursa Major. It's moving gradually, but keep in mind this field of view wouldn't even fit the full moon in it. We're looking here at a very small piece of the sky, especially zoomed in like this, so you will see it move from picture to picture. Alias Mike from around the world. Okay, I'm not familiar with him. I would not put your trust in anyone Paul Begley brings on, though, okay? This is the same guy who promoted the Comet ISON hysteria that turned out to be nothing. And I told you guys, like, years ago, the pictures that Paul was showing was silly. It was just due to parallax from Hubble's orbit around the Earth, and he was claiming that it was in fact proof that Comet ISON was a UFO. Let's see if the comet moves. Yep, it moved. It jumped from here to here. So if we watch from picture to picture, you're going to see this comet moving in real time. That's pretty cool. Is this visible with the naked eye? Not at the moment. Not at the moment. Let's see what Aerith.net shows. Aerith spelled, I believe, like the Final Fantasy character. Is a great website, actually, for comet information and the latest on some of these comets. So they show a chart, a graph of the brightness as it was recorded latest. Looks like it's kind of starting to hit magnitude 8, so it's not too far below naked eye brightness, but it's not quite there yet. It's close. It's close. A trained observer can theoretically see down to about magnitude 7 from pristine dark skies with averted vision and really trained, good high eyesight. you can see down to about magnitude 7, but that's for point-like light sources. This is a fuzzy little object. It actually has a little bit of size to it. So I don't know if that necessarily quite applies. It may need to get a little brighter to even be visible to trained observers. But you certainly wouldn't see it from suburban skies, even at magnitude 7. And really, you wouldn't expect to really see it from suburban skies until it gets up to a magnitude of, say, 3 or 4 at the least, depending on its angular size. But I'll post a link here in the chat to Aerith.net's page showing Atlas and the latest data. It also shows a sky chart of where it's going to travel through the sky over the next couple months. Yeah, it moved. We can see it moving. So here we go. Real-time tracking of this comet here on Astronomy Live. Very happy to see this. We're getting motion from picture to picture. Here comes the next picture. Watch it close. You're going to see the comet move. Boom, there it goes. Real-time celestial motion captured. Not bad, not bad. It wasn't Aerith, maybe I'm thinking, wasn't Aerith like the character who was, spoiler alert, killed in Final Fantasy 6 or 7 or something? I don't know. It's been many years, but I remember back in the 90s or early 2000s, like, that was a big thing. Sephiroth killed some female character in one of these Final Fantasy games, and wasn't her name Aerith, I thought? I don't know, some Final Fantasy fan I'm sure will correct me in the chat, but I thought that was her name in that game. And I think aren't they releasing a remake, or not a remake, but a remastering of it this year? Yeah, Comet Atlas, C2019Y4 Atlas, which Atlas is the name of the observatory that discovered it. I believe it's in Hawaii, and I could be wrong, but I believe they're planning to set up other sites around the world too. And Atlas is an acronym, which is kind of interesting. Let's see, what did it stand for? It's kind of got an ominous name. Yeah, here we go. The Asteroid Terrestrial Impact Last Alert System. Boy, isn't that ominous. It's a robotic astronomical survey and early warning system optimized for detecting near-Earth objects a few weeks to days before they impact Earth. Funded by NASA, developed and operated by the University of Hawaii's Institute for Astronomy. I'm just reading from Wikipedia here. Started operations a couple years ago, if I remember right, around 2017, I want to say. And currently they have an active site. Where is it? I thought it was in Hawaii. Yeah, they're on a couple of islands in Hawaii. There's actually 2 telescopes there, spaced about 160 kilometers apart, which I assume gives them a bit of parallax, that they can kind of get stereo vision of a near-Earth asteroid. If it's particularly near to Earth, they should probably be able to detect a bit of difference in the position between the 2 telescopes and get a good idea of the distance to the asteroid from, relatively short periods of observation. I'm making some assumptions here, but I would think that would be part of the strategy there. So, full Atlas concept consists of 8 50-centimeter diameter f2 Wright-Schmidt telescopes. I'm not familiar with the Wright-Schmidt design. That's interesting. The Wright camera design, presented by Franklin Wright, Berkeley, California, 1935, just a few years after the introduction of the Schmidt camera, was a short alternative to the original arrangement. Wright placed the Schmidt corrector at the focal plane and had the mirror a spherized to cancel coma, resulting from the altered aperture stop position. That's interesting. So it's a variation of the Schmidt-Cassegrain design. Or just Cassegrain design, I guess. Well, no, it's Wright-Schmidt, so I guess it is Schmidt, but with a variation of that theme. Will it think it will be as big as Hale-Bopp? No, I don't think it'll be as big as Hale-Bopp. But like I said, it might get naked eye bright. It might make a nice display as it gets closer to the sun. And you can see it moving here. Fireballs, meteor storms. Well, we're not going to get any meteor storms from this comet. The Earth minimum orbit intersect distance for this comet is 0.63 astronomical units according to JPL. I'll post the link here in the chat. So what that means is that the orbit of this comet gets no closer than 0.63 astronomical units to Earth's orbit. The upshot of that is it's impossible for this comet to give us a meteor shower. Meteor showers generally do come from comets, leaving behind debris, material left behind by the comets in its orbit that we run into year after year as we travel through our orbit. If the orbit of a comet intersects our orbit and it leaves behind that debris, we'll continually basically pass through that field of debris and experience a meteor shower. But this comet does not come anywhere close to Earth's orbit, so it will not generate fireballs, meteors, or anything else that we're going to see in our night sky other than the comet itself. So, sorry to say, but no, it's not going to affect Earth in that way. It's not going to give us a meteor shower, it's not going to give us fireballs, it's not going to do anything exciting like that. Hey, Everyday Astronaut. Hey, welcome. We're just streaming here, Comet Atlas. We can actually see it moving between pictures. So we're about to get a new picture here, and you can see the bright comet here and its tail extending up to the top left of the image. When the new picture comes in, you will actually see that comet move from picture to picture. And there we go. So it moves against the background stars, and we're just tracking it here. Oh, thanks, Everyday Astronaut. Well, that might explain why I've got so many viewers tonight. Appreciate it. Yeah, Tim Dodd and I are collaborating on a project here to track rockets using a telescope loaned to us from Oceanside Photo and Telescope, OPT. And we've got a 10-inch LX200, even bigger than the LX200 I'm using tonight, for tracking those rocket launches. So next time Tim comes into town for a rocket launch, we'll try to improve that project even more. I've got some ideas to implement so that the tracking is not only smoother, but hopefully more predictive as well. Where am I tracking it from? I'm tracking it from my house. So I'm over on the west coast of Florida. A van down by the river. No, not a van down by the river. What is the current magnitude of the comet? Well, according to airth.net, it's around magnitude 8 now. So it's getting on up there in brightness. I'll again post a link and you can see a graph of the latest measurements. And actually, look, no, that looks about right. That looks about up to date. Oops. Didn't mean to pull that off. Okay. Where's the chat? There we go. Yeah, Dick Dawson, if you haven't subscribed, you need to go subscribe. Everyone, if you haven't subscribed to Everyday Astronaut, what are you doing? Go subscribe to Everyday Astronaut. Yeah, that's a great question, Tim. So, post-processing, actually, I had an idea for this. Normally, in the past, the way I've post-processed comets like this that are moving very quickly is manually. having to stack the images. I do 2 stacks, one aligned on the stars, and then one aligned on the comet. And then I basically merge those in Photoshop so that I have frozen both the stars and the comet. What I'm going to try this time is, well, first of all, I do have a program I've been tinkering around with for automatically aligning based on the orbital elements of the comet. So it'll automatically align the images based on the orbit of the comet, so I don't have to do that manually, which is a huge help when you have a lot of images to stack. And then I could get really fancy with it, I suppose, and try to even basically streamline the processing pipeline so it's all done in Python. But at the very least, doing the comet stack sort of automatically based on the orbital elements is a huge help. That saves a ton of time. And right off the bat, you have a nice picture of the comet, because even if you haven't aligned it on the stars, and the stars are streaking behind the comet, that still looks like a nice picture. So right now the program I've got to do that only works with grayscale images, but I'm shooting color images tonight, so I'll have to modify it a little bit so that it can handle color image processing. So that'll be interesting. But these are FITS files, which are pretty easy to work with. These are raw FITS files, the same type of files you would get off the Hubble Space Telescope, really. And it's a pretty standardized data format for astronomy. It's just raw pixel values. In the case of color images, you have kind of like 3 FITS files sort of built into one. 3 layers all in one file. So I just have to rewrite the program a bit to handle all 3 layers. So that'll be interesting. I will post the source code for that. It's a pretty simple little script in Python. So when I make the time lapse on this, I'll post the source code to my stacking program if I'm able to rewrite it for color images, and people can use that, because like I said, it saves a huge amount of time. If you have a dim comet, if you have a bright comet like this, it's not so bad. In Deep Sky Stacker, you can align on the comet. But if you have a really dim comet that Deep Sky Stacker can't see, it's really tricky to align on the comet. So being able to just do it fully automatically, just dump it into a script and feed it the orbital elements and just have it run off that, huge help. Did I get a chance to check out the Linux software options yet? Oh, for running the camera? I'm set in my ways, Andrew. I'm set in my ways. I'm so used to processing and just, well, not processing, but just using CCD soft for running the camera and the adaptive optics. I'm really hesitant to mix that up. I probably should dabble in it, but I just haven't had, to be honest, I haven't had the time to dabble in it. And it's not broke, so I'm not fixing it yet, but it's almost broke. So CCD soft is ancient software, for those who don't know. It's really built for Windows XP and nothing after that point. And it does have certain incompatibilities with Windows 10 that I just have to work around by live streaming on a separate computer and just HDMI capturing the view from the software. That is actually working around one of the limitations of it. So yes, there are options in Linux for operating this camera. I have a feeling they're not as user-friendly as this, but yeah, dual boot. I should just dual boot. I dual boot on my desktop. I do. I have Linux, Mint, and Windows 10 set up on my desktop. This is a cruddy little laptop I got pretty cheap. That's actually operating the camera. The live streaming laptop is a much nicer, newer laptop. Yeah, I should probably look into dual boot. Yeah, that's further down the list of priorities, though. Well, top priority for me on Linux projects right now is actually pulling some of my programs off of a Linux box I have in my office right now, where I'm running real-time processing of SDO, Solar Dynamics Observatory images, and annotating them. And the laptop that's running that is on its very last leg. It is, I think the hard drive is failing on it, and I just need to pull all that stuff off and throw it on an SSD or something else where I can just clone it. And if it goes down again, I can just clone it and bring it back up. So I got to work on that. That's top priority before I try to fool with my camera setup. Oh, Dick is... Sorry, I missed your comment there, Dick. You're inviting me onto the shills for some space denier debunking. Maybe I could bring Tim. I don't know. I don't know if Tim wants to get into... I mean, I would love to have him, but, you know, I think Tim's mission, and I'm not going to speak... I shouldn't speak for Tim, but I feel like his mission is you know, educating those who want to be educated. And he could speak for himself, but... I don't know if he would feel quite at home on the shills. Yeah, I mean, it's up to him. I'm not gonna twist his arm on it for sure. But I'm happy to join you guys again if you want me to. But yeah, what speak for you? Yeah. I shouldn't speak for you, Tim, but you know, like your slogan says, what's your slogan again? Bringing space down to Earth for everyday people. I mean, that's kind of... I'm probably butchering your slogan there, but that's the general gist of it, right? Bringing space down to Earth for everyday people. Flat Earthers are, frankly, not everyday people. Space deniers, again, generally not everyday people, and just usually doesn't help them. I could get on my soapbox about that, actually. I have my own thoughts on all of that. You know, you can't help somebody who doesn't want to help themselves. And I enjoy debunking. I do. I'm guilty. I've got debunking videos on this channel. My latest video is debunking somebody who was claiming my rocket launch footage is fake, you know, because they said it was 20 seconds too long, whatever. And sometimes it's just entertaining to sort of examine those claims. I'm not as interested in confronting the personality. I'm interested in examining the claim and finding some way of addressing it. Because oftentimes in doing that, I teach myself something. A good example of that would actually be my rocket tracking software. I mean, I'll be honest, that started from a place of knowing that SpaceX was going to shortly start landing their rockets vertically. They were already in the process of trying to get that up and running when I started developing my rocket tracking software. And the motivating factor for me was not just improving my rocket launch footage, but providing independent proof that they were actually landing their rockets successfully. It hadn't actually happened yet. The first successful landing hadn't happened yet, but it was clear they were getting close. And so I was motivated by the desire to provide independent proof to, I guess you could say, debunk some of the space deniers. But again, it wasn't about confronting their personalities. It was about addressing the claim that, for example, SpaceX isn't actually landing their rockets. It's silly, yes. But in doing that, I learned a lot. I learned a lot about Python programming, about OpenCV, about how to do video-based tracking. I taught myself a lot of concepts, all because I was motivated by the desire to provide independent proof of something that most average people would accept at face value as happening, because everyone shows it's happening. I know we got tons of witnesses down there that see these things happen. But I think it was beneficial, at the very least for me, to be motivated by that in a positive way. And so now when I film the launches, yeah, okay, it's bonus to me if it helps prevent people from falling into rabbit holes, as Mick West says. But there is the primary motivation is sort of transformed into how good can I make my footage? You know, how can I improve the quality of the footage itself from a photography standpoint? And so, for example, one of the things I'm working on now, right now, my rocket tracking software is, you might say, empirical. It's all based on either joystick input or video-based tracking of whatever the rocket's doing. But it doesn't know ahead of time what the rocket's going to do. I want to get it to that point. So I'm definitely looking into coordinating and collaborating with Flight Club, flightclub.io. If you aren't a Patreon of Declan's, you need to check that out. If you have any interest in photographing launches, you should seriously consider subscribing to his Patreon, because his website offers photography tools for planning your observations of various rocket launches and seeing what the arc will look like. So behind the scenes of that, under the hood, as it were, he's predicting the trajectory of these rockets as they go into orbit. If I can collaborate with him, maybe I can load that trajectory information into my program for tracking the rocket with a telescope. And then even if the telescope loses sight of the rocket, if it goes behind a cloud or something, for example, it will continue following, not just based on the last known velocity, but actually predict what the velocity will change into, how the rocket will accelerate or decelerate, whatever it's doing, while it can't see the rocket, based on the predicted trajectory. That way, when it reemerges from the cloud or whatever, even if it's gone for several seconds, it should still be in the field of view. That would be spectacular, I think, and provide a real resource for amateurs everywhere to provide better footage, get better footage of these rockets with off-the-shelf telescope hardware. For example, the LX200 loaned to us by OPT telescopes. So what started as just a, hey, let's get some independent proof that this is really happening, has turned into an awesome project of just improving the raising the bar and improving the footage that amateurs are able to get with off-the-shelf telescope hardware. And Red's Rhetoric's now using my software. Cosmic Perspective and Tim Dodd at Everyday Astronaut, they're using it with the OPT telescope. So it's great to me. I get such a feeling of reward out of it, even when I'm not there at a launch. Like, I wasn't there at the launch this week, but I still knew my software was being used on 2 different telescopes that were out there that time. So that's fun to me. That's really exciting that I'm able to help others get the footage even when I can't be there myself. So it's been incredible as a journey. So yeah, let me link Declan's website here, and if you join his Patreon, you can also join the Discord server and chat with him there. It's a good bunch of guys you'll find on there too. All the major SpaceX photographers you see on Twitter and so forth, you'll generally find them in the Discord. John Krause is on there. Bunch of guys who are really good at this stuff. So yeah, go check out flightclub.io and you can see predicted trajectories of upcoming launches and past launches as well, and simulate rocket launches yourself. You can customize it as well. So really handy tool. Yeah, no problem, Dick. And then we have a series programmer like Andrew Kroll in the chat. Everyone using Linux kernel, including Android, is using stuff I wrote. Yes, it's a strange feeling. Yeah, wow, that's that's accomplishment. And a super chat from Everyday Astronaut for $19.99. If you're watching and learning from Scott, hit him a like and a sub. His knowledge is top notch. And if you happen to spare during these wild times, send him $1 for his awesome work. Thank you, Tim. Appreciate it, man. I love working with you. Hey, Dubé. Thanks for coming. Hope you enjoy it here. We're watching Comet C2019 Y4 Atlas. It's getting closer to Earth over time, and it's getting brighter. It'll be reaching closest approach to Earth in about 2 months, and it's already around magnitude 8 or so, according to Aerith.net. And as you watch the images come in here, from image to image, you will actually see this comet move over time. You can see the tail moving up to the top left, kind of angled up towards the top left in the image. And you're going to see the comet moving down towards the bottom right in the image. Yeah, it's definitely outgassing quite a lot. So what causes the tail? That's a great question. So the tail is pushed back by solar radiation pressure, and you've got some comets you get a distinct two-tail formation from an ion tail where the gas is actually being ionized, and then the dust tail. In this comet, I think we're predominantly seeing a dust tail getting pushed back by solar radiation pressure, or these tiny little dust particles. The solar radiation pressure is quite significant, and so the tail basically points away from the sun, and this comet's heading towards the sun right now. So yeah, solar wind. And we got a new sub for Everyday Astronaut. That's funny. I would have thought that my my viewer base like 100% overlapped with Tim Dodd, but I guess not. So yeah, if you're not already subscribed to Everyday Astronaut, please go check his site out. Go check his YouTube page out and subscribe. He's also got I'll plug his website too. He's got some fun T-shirts for sale there. Are there any planets in this frame? No, not that I know of. Now, you know, maybe these stars in the frame have exoplanets orbiting them. They may even have known exoplanets orbiting them. I haven't cross-referenced it against the any exoplanet databases. That'd be fun to see some night, actually. It wouldn't be as visually interesting, but we could do some photometric work and see if we could detect maybe a larger exoplanet transiting its star and causing momentary dimming of that star. But wouldn't be as visually interesting as tracking this comet. Well, hey, I gotta plug it because I don't have fun T-shirts for sale, but you do, so. I mean, come on, who doesn't want a Falcorn Heavy T-shirt? That's awesome. I should watch a 6-hour exposure. I wish I had 6 hours to devote to this comet, but I do have to work tomorrow, so at some point I have to turn in. Are we all going to die for the comet? Only if it's carrying angry aliens. Yeah, maybe if there's little green men on it, but I don't expect that to be the case. Got some mosquitoes flying around here. I thought it would have been too cold for them out tonight, but it's really not. Working from home? You're not wrong. I am working from home right now. Are we going to die because of this? No. Is it the cause of global warming? Nope, definitely not. Yeah, no threat to our weather climate, no threat to the Earth itself. It's not going to cause a pole shift or anything else. I've started to hear rumblings in conspiracy circles of various things that they are going to attribute to this comet, but no, it's just another normal comet. Just brighter than most. And it's not even going to get all that close. I mean, 3/4 of an astronomical unit, somewhere around there, maybe. I should check on Sky Safari again. Let's see. Yeah, that looks about right. About 0.78 astronomical units, then it starts increasing. Yep, Sky Safari agrees. Yeah, a little more than 3/4 the distance to the sun at closest approach from Earth. So, not all that close. Hopefully it won't cause another Heaven's Gate. That's a great point, Andrew. That's a sobering point, is what that is. And I remember that incident from high school. I was in high school when that happened. So for those who aren't familiar with it, maybe too young to remember, gosh, over 20 years ago, I guess it's been now 23, 24 years, somewhere in that range, when Comet Hale-Bopp came through the inner solar system, there was a cult known as Heaven's Gate. And a rumor got started, and it kind of got popular, as I understand, on Coast to Coast AM, that a UFO was tailing the comet. And the cult took this as a sign that the aliens had come to pick them up. And they needed to beam up to the mothership. Unfortunately, they did this by sacrificing themselves. And I mean, ending themselves, unfortunately. So it's a sobering reminder to be responsible and to be honest with people about what's really going on. And yeah, it was a tragic incident, and perhaps you could say that was inevitable, perhaps, with that cult. Whether or not somebody had started that rumor for that comet, it would have happened sooner or later. But it's a sobering reminder to be responsible and not spread misinformation. And a super chat donation from Primera B for 500 PHP. I'm not sure what currency that is, but thank you very much. Is that Philippines, maybe? Yeah, you remember that, Tim? How many images will I be taking? Well, at least 20. We're coming up on 19 right now. I mean, I'd like to get 30 pictures down, but let's see, what time is it now? It's 12:18. I mean, I could go till maybe 1 a.m. So, oh yeah, no, I can get easily 30, 40, 50 pictures down, perhaps. Philippine pesos. Thank you, Andrew. Yeah. Yes, it's Atlas we're seeing now. It's this white comet here. You can see its fuzzy appearance, its fuzzy tail angling up to the top left. I mean, the crazy thing is this comet is circumpolar, and I could basically track it all night, but at some point I do have to get some sleep. If this were a weekend, it would be even better, but I would go all night, but I do have work in the morning, even if I am working from home at the moment. Curious what the weather forecast calls for tomorrow. Looks like it should be pretty clear through tomorrow night. Not quite as clear as tonight. Oh yeah, no, that's not going to be clear. Sometimes clear sky clock's a little deceptive. It will show you a tight window where you're located, but really the context around you might indicate it's not going to be as peachy keen as you might think. So yeah, tomorrow night probably won't be as good. But hey, at least we're getting the comet tonight going by this bright star right here. What star is this? See if I can identify this on Sky Safari. So looks like that is going to be, oof, that's a long name. Oh man, I don't have another name for it. Okay, it's this is a long one. It's a Gaia designation. Gaia 10691290334200725576. Yeah, that's a mouthful. Unfortunately, that's the only name listed for it in Sky Safari Pro. So there you go. That's the designation of this star that it's flying by right now. I knew it. I knew it, Sam. I knew that's what you were referring to. It is. It's like Data reciting Picard's access code. Somebody needs to turn that into a meme right now. Maybe I should change my password to use that. No, I can't do that. I already just admitted it. So everyone's going to try my password now with that number. As soon as you said Mark, as soon as I saw you said Mark, Sam, I knew that's where you were going with that. This is the live image. Yes, Hina, this is a live image right now. Each image is 2 minutes long. It takes 2 minutes for the camera to expose the light, and then it pulls the image up live. So you are seeing the actual live image. Oh, did you look it up, Astro Channel? Does this star have extra exoplanets? That would be cool. If we're happy to look at the comet flying by a star that has exoplanets, man, that would be some synergy right there. I'm gonna look that up myself right now. Okay, now I gotta type in that long number myself. Okay, I'm gonna look it up on Simbad. I don't know if they've got this one listed in their database, but maybe. Okay, how do you... Okay, found it under this. No object found. Okay, that's weird. Simbad's being weird to me. It's not showing up in Gaia Data Release 1. Maybe it's in DR2? I don't know. Okay, well, Astro Channel, if you have a link to where it's listed that this has exoplanets, or maybe you're referring to something else, I don't know. I tried looking it up on Simbad database right now and couldn't find the number. I don't know. Sky Safari Pro might be formatting it weird or something. I really should just go to the Gaia database and look it up directly that way. Or I could put in the coordinates. I mean, that would be the other easy thing to do, is a coordinate query. Okay, let's see. If I switch this, I gotta switch this to J2000 coordinates. Right now it's on epoch of date. So let's do J2000 instead. And now let's put in the coordinates 09, 21, 33.18 space 67 space 17 space 0.5. Okay, let's see if there's anything. Nope, there's nothing. Okay, so Simbad doesn't have this object in their database at all. Well, chances are nobody's ever published on this star then, so I'm guessing it doesn't have an exoplanet. Because pretty much if anyone's published on the star, it'll show up in Simbad's database. But oh well, it's cool anyway. We get to see this comet flying right by this bright star. That's pretty cool. All right, Tim. Thanks. Thanks for coming, and thanks for tweeting about it. Have a good night, man. Oh, thank you, Amol Joshi. Wow, that's a really nice compliment. You're a professional software developer. Well, I tell you what, I make no bones about it. I am not professional, and my code is terrible. I get the job done occasionally, but yeah, it's been a means to an end. At least that's how it started. And I've been self-taught. I'm entirely self-taught when it comes to Python. And that's basically the only language I'm proficient with. But I really appreciate that. That's a really high compliment and praise from you. I think it helped a lot that I did take a course on observational astronomy when I was an undergrad. And I learned a lot of the sort of the fundamentals of doing astronomical-based calculations. Converting coordinate systems, calculating sidereal time, all that kind of stuff. And really gave me a good grounding, a good foundation for it. So then I dabbled in developing these complex spreadsheets for doing things like calculating the position of the moon from its orbital elements, or really from a really lengthy Fourier series, which was developed by Michelle Chaparron-Touzé, and I'm butchering her name, I know I am, but I think it's ELP2000 is the name of it, the algorithm. Anyway, it's an algorithm that she and her husband developed primarily as a pseudo-analytical, I think it's a pseudo-analytical solution for the moon's orbit. Anyway, it's pretty accurate out to several thousand years in the past and the future. And developed that into a spreadsheet for calculating field rotation of the moon and rise and set times and all of that. And it kind of whetted my appetite a bit, and I realized pretty quickly that doing this all in a spreadsheet is not the most efficient way to do it, and I really should pick up programming again and learn a programming language to do things like this in the future. So got into Python programming from there. So yeah, now I develop things like Comet tracking software and rocket tracking software and satellite tracking software and all that kind of stuff. And I should link my GitHub page. Like I said, my code is not professional, and you'll be able to tell pretty quickly in how I use or fail to use classes properly, and commenting of my code, it's not thoroughly commented. But anyway, here is... Nope. Come on. Come here. I'll get to it eventually. Here's my GitHub page. So I've open sourced a lot of my code. Not my rocket tracking software yet. Honestly, having to get a little bit of legal advice on that for liability reasons. But yeah. How fast is the comet going? Ooh, interesting question. Fast? I'd have to crunch the numbers on that. I don't think Sky Safari Pro tells me that information. Well, okay, I got radial velocity at least. Radial velocity relative to us is 8 kilometers per second right now. Apparent motion is currently listed in arc seconds per day, or seconds of right ascension per day. 914.9 arc seconds per day in declination, negative 416 seconds of right ascension per day. But that doesn't really mean much, of course. If you factor in the distance and do the trigonometry on that, you could get the radial or the translational rates and figure out the total velocity relative to Earth, and maybe translate that to Sun relative velocity. But Sky Safari Pro doesn't give those numbers to me directly, which is unfortunate. Be nice if it just gave me those numbers. But yeah, it's closing in on us at 8 kilometers per second right now, but it'll stop when it hits about 0.78 astronomical units, and then it'll start getting further away. Yeah, from a legal perspective, I was just worried about, with my rocket tracking software, liability issues. For example, my rocket tracking software allows you to have free joystick control of the telescope. Even my satellite tracking software doesn't do that, and I do make some warnings in there. Be careful during the day. You don't want this thing pointing at the sun. But especially with rocket tracking, if you're tracking a daytime launch and somebody, foolishly steers their telescope through the sun and at the very least blows up their camera and melts their telescope, or in worst case scenario, somebody's looking through the telescope when that happens and they blind themselves. I do not want to be responsible for somebody losing an eye. It scares me to death, and that's why I haven't released the rocket tracking software. However, I've gotten pseudo-legal advice, I guess. It's not really from a lawyer I've retained or anything, but from quote-unquote legal experts say that the license that you would have with open source software, like whatever you use these days, will generally have protections on it that would protect you, indemnify you even from negligent misuse that leads to physical harm, or negligent misuse that leads to harm of someone else. That someone else may not be the person who actually downloaded your software. Maybe somebody else who's looking through the telescope, but I don't want them to be able to come after me. So, according to people I've talked to, yes, I would be indemnified even in that scenario. But I want that in writing. I want that to be locked down tight before I consider distributing the software. Because that you know, that'll end your whole life right there. $1 million lawsuit because you blinded somebody with your software. Technically, they blinded themselves looking through a scope that was irresponsibly steered close to the sun, but, you know. You hear these horror stories of people getting sued over things like this, and I don't want to be that person. Yeah, exactly, Josh. I think it is a legitimate reason to seek legal advice, and really what I need to do is I need to actually pay a lawyer to be my lawyer to actually give me formal legal advice and an opinion on all of that before I go and release it. Yeah, and I probably would do that, Sam, in terms of adding an annoying pop-up that wouldn't allow it to work till they clicked agree. I mean, they could always take it out of the code. That's the point of open source software. You can always modify it. But at least it's there to begin with, and it's their own fault if they ignore it. But even then, I don't want it to be said that, yeah, okay, you showed us this warning, but you didn't really prevent us from doing anything that would harm us, you know. Oh, that's a great question, Kelsey Black. Can the software be soul aware? I've thought about that. The problem is it usually wouldn't be, because oftentimes, for example, if you've got a Nexstar scope, my software is compatible with Nexstar. For example, the mount that Red's Rhetoric used to film this latest Starlink launch was a Nexstar scope. When you fire it up, you can immediately start using it with my software, but the telescope, the mount, doesn't immediately know where it's actually pointed. And so he just plops it down on the ground somewhere. He doesn't really have to care what orientation it's in when he turns it on, especially for tracking rockets. But when he does that, it's not going to know where the sun is. It's going to have no idea. In fact, the pointing data that it returns to the software at that point is essentially meaningless. It's not accurate at all. And so it wouldn't actually be soul aware, and worse, from a functionality standpoint, it would be incorrectly aware. It might think that it knows, and it doesn't. It might think the sun is 180 degrees from where it actually is in the sky. And so it might try to stop you when you're just trying to track a rocket and you're nowhere near the sun. And conversely, it wouldn't stop you at all when you are near the sun. So what does that do? That gives you a false sense of security, is what that does. So I absolutely don't want to do that unless it's actually going to work, and it's not. So, yeah, no, I haven't thrown that in there. They've been sued for people losing their fingers. Ouch. And since they accepted the terms, they had no case. Yeah. I mean, that is the thing. Yeah. My client has an accept screen too. Okay, so you've had to deal with that situation then. Yeah, I just want to make sure that I'm battened down on those hatches before I release it. Yeah, the problem is with trying to code inside the telescope to prevent it pointing at the sun. Most scopes don't really do that so well, even mine. It's funny, if you're setting up the telescope during the day and it's aligned and it actually knows where it is, if you type in the coordinates for the sun and you hit go to, it won't do it. It'll say that's too close to the sun, but it won't tell you where the sun is, even though it knows where the sun is. And it also won't stop you from moving through the sun with my software or any other software. If you manually steer it using the buttons on the hand controller, for example, you can steer right into the sun. It's not going to stop you. It's only the automated go-to, only the automated slew to a particular set of coordinates that it will stop. Anything else, it permits. So, and that's hard-coded into my telescope. I can't change that. That's built into the design. And so that's just a hard limitation, and that is true of a lot of telescopes. And so I have to live in that world and just deal with that reality. And so there's no practical way or easy way for me to restrict my software from ever theoretically pointing at the sun. For myself, that's okay. For Red's Rhetoric, that's okay. I know he's not going to do something silly, and in his case, even if he does, the worst he's going to do is blow up his camera. There is no optical path through his camera that you can stick your eyeball into. So the only thing at risk is his equipment. But for a lot of people, if they're using a telescope, the risk is actual blindness. And so that's just a, it's just a concerning thing. And of course, if I do release it eventually, I will have all kinds of disclaimers in there, warning screens that pop up and say, I mean, I could even say, don't use this during the day, but that kind of defeats the point of tracking most, or at least half of rocket launches, day launches. Not really what I want to do. But my advice, my honest to God advice on that would be, put whatever you're using, your telescope, in the shade of a building. And if the sun changes its position and you're no longer in the shade, stop using it. If you're in the shade of a building, you can't point at the sun. You're going to point at the building. And so that's just an easy physical barrier between you and the sun. It's a it's an engineering control, as we would say in the lab, an engineering control to prevent you from injuring yourself. Most people probably aren't going to abide by that, but that would be my advice. Have a light sensor. Yeah, and that's a good point, Andrew. If they are using video-based tracking, I could certainly implement something like that. But from a computer vision standpoint, it's actually a challenging problem. How do you differentiate a really bright rocket from a really bright sun? Depending on the camera exposure of the whatever camera you're using, which you're not going to know ahead of time what camera it is or even necessarily what exposure it's using. For example, if I use my Samsung security camera for tracking launches, the camera exposure is controlled internal to the camera, and that's not really visible to the software. It doesn't know. It has no way of knowing what the camera exposure or aperture is set to. It just sees the images from the camera. And a really bright white source could be a rocket launch, especially a night launch. It looks like the stinking sun to the camera. And so it's a really challenging computer vision problem, to me at least, is how do you differentiate a really bright rocket from a really bright sun? Because you want to track the rocket, but you don't want to track the sun. You could look at the motion of it, yes, but even that's not necessarily guaranteed. For example, boost back burn with the Falcon rockets. When they do their boost back burn, there's a certain point where the rocket's basically just hanging in the sky. And depending on what camera you're using, again, if it's really sensitive to infrared and it's really sensitive at night, it's going to look like a stationary bright object potentially. So depends on a lot of factors, but yeah, there's a problem there. Even with motion, it may not be possible to distinguish it from the sun, just from a pure a priori detection standpoint. The shape, OpenCV. Yeah, the shape, but again, you'd be surprised. Some of these rockets, they look round. They're so overexposed at night. Even when I try to speed up the exposure a bit or turn down the iris a bit, I tend to underestimate just how bright they can be. They get so overexposed, they just look perfectly round and perfectly white. I tell you right now, to any program I could write at the moment, it would be no different than pointing at the sun. Not going out for a while, not gonna get stabbed over kids. So yeah, be safe out there. I'll be honest, I stocked up a bit before things got crazy, and I'm kind of wishing I'd stocked up even more just to have an extra reserve there. But I've got plenty of food and stuff for now and whatnot. But jeez, I hope things start going back to normal soon. I'm watching a 1 in 100 year. Well, I wouldn't call this a 1 in 100 year comet, but it's a nice comet. It's better than we've had in quite a while. Another mosquito wandering around here. He wants my face. Go away. And people are talking about toilet paper in the chat. That's funny, isn't it? Ooh. A solar filter on a cadmium sulfide photocell. Nice. Bet that makes some nice images. You said you were stuck inside with no toilet paper for 2 weeks. Oh man, that's a bad way. Can't image with the cadmium sulfide photocell, only detect light, which is the point. Okay, yeah. Good point. Well, I suppose if you had an array of photocells, you could make an image out of it. But yeah. I was thinking, I got it confused in my head. I was thinking cadmium solar filter. Or calcium not cadmium. Man, I really had it confused in my head. Sorry, it's late. I'm going to blame it on the time. But I was thinking calcium solar filter for revealing some of the detail in the chromosphere. How close is Atlas to Earth? No closer than the Sun. It's about 1.09 astronomical units right now. And at closest approach, it'll only be about 0.78 astronomical units away, which is a little more than 3/4 the distance to the Sun. So, no, it's not going to hit us. It's not going to harm us. It's not even going to make a pretty meteor shower in the sky. The minimum orbit intersect distance is more than half the distance to the Sun, and so we won't be getting any fireballs from this one. The stream is in the afterlife now. Yeah. Well, maybe because of the virus. The virus that shall not be mentioned. I probably shouldn't even say the V word. Get demonetized. See, this is supposed to be everyone's escape from all of that. Oh, hey, this image shifted. I hope the next one goes back to normal. Let's see. Yep, it went back to normal. Okay. One little defective image is okay. If it becomes a pattern, then it's a problem. What is the magnitude of the comet right now? Around magnitude 8, according to the latest data that I've seen. Maybe just above magnitude 8. Alrighty, well, what exposure length? 2-minute exposures, 0.1 second exposures on the auto-guiding with a guiding rate of about 6.8 hertz. Actually, that might have changed a bit. What are we at? No, we're still at 6.8 hertz. That's good. How close? 1.09 astronomical units, a little bit further than the Sun. So I'm going to turn on some stellar drone music, and I'll be back in a bit. astronomical units, not miles. be wrapping up the stream pretty soon. It's almost 1:30 a.m. When we hit image number 50, nice round number, I'll stop it there. I want to thank everyone for coming. Let's see if there's any last minute questions here in the chat. Who would downvote this? Yeah, Flurfs would. Flat Earthers, Space Deniers. Yeah, you always get some people like that, but that's okay. As Sam pointed out, it's all interaction. Interaction with the video drives eyeballs, generally. Yeah, I guess I'm just a little OCD about it. It's just nice to stop on a nice round number like that when possible. Well, thank you, Amy Hogan. It's pleasant and nice to have you in the chat. Hope to see you around on the shills, and I'll be happy to join you guys later if you want to have me on for another show. That'd be fun. Oh, you mean... Andrew, you mean an actual square of a number? That would be fine, yeah. But, no, we're going to wrap it up here in a bit. One more image. If this were a weekend, I would keep going for longer, but, gotta be responsible and call it quits sometime. Get some sleep. Yeah, I don't foresee Tim Dodd debating with Space Deniers anytime soon, but I do thoroughly appreciate what he brings to the community and the educational content. Sounds like he's just wrapping up his rocket pollution video. Alright, that's going to do it for me. I'm going to go ahead and stop the auto-guiding, stop the imaging. Looks like it saved the images. That's always good. Whiskey Sadie had a comment question I might want to field. Okay, well, sorry, if you can repost it, or maybe I just missed it. Was it about the... Okay, always thought there has to be a way to bend light to make a more powerful telescope that nobody thought of yet. I mean, the most common telescopes are incredibly simple in how they function. Yeah, I think there is a proposal to put a telescope very far from the sun and use the sun as a gravitational lens to basically act like a gigantic telescope. I could be wrong, but I thought there was some proposal to do that that would produce really, really high resolution, angular resolution. Maybe even be able to image exoplanets and stuff. Who knows? But that would be awesome. I'm a lot quieter now than before the break. Sorry, let me get a little closer to the mic. I might just actually be too tired at this point to raise my voice enough. Yeah, hope to see Tim back here pretty soon for more launches. I think it'll be really fun to collaborate with him on filming some of those things and getting really high quality footage. Yeah, I don't know if it was just a paper telescope or if there's any real serious work being done to make it a reality, but I hope so. It sounds like an exciting idea for sure. Hey, Cy Strikeling. Sorry you're joining right as I'm about to wrap it up here. I think you might have been streaming earlier tonight, but yeah, it's clear here, so I figured I'd go ahead and do a stream. I don't think it'll be as clear tomorrow night, but tomorrow night I might just focus on stacking all the image data. I collected 50 images here tonight. Gonna revise one of my little programs to automatically align these images based on the orbit of the comet, hopefully. So we'll see how that goes. Alright, well, thank you all for joining, thank you all for watching, and if you haven't already, consider subscribing to my channel to see more content like this, and also be able to get access to my open source software for things like comet stacking, comet tracking, rocket tracking, satellite tracking, all these fun things, projects that I engage in here in amateur astronomy. Alright, thanks again, and clear skies, folks.